Hello everyone, I welcome you all to this class. This is mathematics class. Today we'll be looking at this example on this topic we introduced in our previous classes, limit of function. Now today we'll be looking at limit at infinity. So I'll show you how to evaluate limits of a real valued function or real variable at infinity. So we have these questions listed here. We are going to solve it within few minutes using the shortcuts I will tell you. So if you want to evaluate limits of real valued function or real variable, and you have a function like this, all these are rational functions. They are functions written in fraction form. You have the numerator, function at the numerator, and the function at the denominator. Both function at the numerator and that of the denominator, they are all what? Polynomial functions. Except this one we're having roots. So, but for this question A and B, we have polynomial numerator and denominator. So if you have polynomial like that and you want to evaluate limit as x goes to infinity. So all you need to do is to locate the highest power of x you have here there. If you locate the highest power of x you have in the question, then your answer will be the coefficient of that higher power of x at the numerator divided by the coefficient of the highest power of that highest power of x at the denominator. So for the first question, we have limit as x goes to infinity of x raised to power 5 minus 5x squared plus 1 divided by 3x minus 4x raised to power 5. So if I look at the numerator and denominator, the highest power of x is what? 5. That's the highest power of x I can see both at the numerator and the denominator. So I'll pick the coefficient of that highest power of x at the numerator. What's the coefficient of the highest power of x here? We're having x raised to power 5. That's the highest power of x. What's the coefficient here? Coefficient of this x raised to power 5 here is what? 1 divided by what is the coefficient at the denominator. So we come to the denominator, the term with the x raised to power 5 is this term, and the coefficient is what? Minus 4. Minus 4. So we have 1 divided by minus 4 is minus 1 over 4. So this gives us the limit of this very function as x goes to infinity. So we are going to do the same, use the same trick in this question B. So we'll look at the numerator and denominator and then locate the highest power of x. So if you look at the numerator and denominator, the highest power of x I can see both at the numerator and denominator is what? X raised to power 4 is the highest power of x. So if you come to the numerator, we don't have x raised to power 4, which means that the term with x raised to power 4 at the numerator is what? 0. That's why we are not seeing x raised to power 4. So we pick the coefficient is 0 because x raised to power 4 is not at the numerator. Divided by, what's the coefficient of this x raised to power 4 at the denominator? The coefficient is what? 6. So 0 divided by 6 will give you 0. So this gives us the value of this very limit. So if you look at this, the last question, we have limit as x goes to infinity of x divided by square root of x squared minus 1. So you may want to use this same trick here where we used in this question A and B, but that trick will not work here. That trick will not work here because we are having roots here. We are having roots. Because of this square root, it will not work. Had it been that we have x divided by x squared minus 1, it would have worked as we did earlier. But this one, since we have square root, we are going to resolve it. So we are going to rewrite this. This will be limit as x goes to infinity of. So we are going to do what? You divide the numerator and denominator by what? X. For you to be able to solve this very question. If you divide the numerator by x, x divided by x will give you what? So we are going to have x divided by x at the numerator. Do the same thing at the denominator. Square root of x squared minus 1 divided by what? X. So I divided the numerator and denominator by x. So we have limit as x goes to infinity. So x divided by x is 1 divided by, we have square root of x squared minus 1 divided by x. So I will make this x to enter inside the square root. If you have square root of 2 divided by 3, you have square root of 2 divided by 3. You want this 3 to enter inside the square root. You have to square it. So you are going to have square root of you write the one you have inside early. So you have 2 divided by, so this 3 will now enter inside the square root. Your division is still there. Then instead of 3, it will be 3 squared for it to enter inside the square root. So if I want this x to enter inside the square root, so I have square root of, so what do I have inside? I have x squared minus 1 divided by, the division will still be there, but if x enters inside, then it will be x squared. I will square it. So this gives us limit as x goes to infinity of 1 divided by square root of. So what you are going to do is you are going to divide each of this quantity you have inside by this denominator, by x raised to power 2. So we will do x raised to power 2 divided by x raised to power 2, you get 1. Next thing you have is what? Minus. Then x raised to power 2 divide 1. You have 1 divided by x raised to power 2. You can now evaluate the limit. So you put x for infinity anywhere you see it. So you now have 1 over square root of 1 minus 1 over infinity squared. Because we're having x squared here. So it will be infinity squared. So this will be 1 over square root of, what is infinity squared? So let's just write what we have here. 1 minus 1 over infinity squared is infinity. So that will be 1 over square root of 1 minus 1 over infinity is 0. So you have 1 over infinity is 0. So this will be square root 1 over square root of 1, which is 1 over 1, which gives us 1, because square root of 1 is 1. So the result of that, of this very limit is of the limit of this very function is 1. So thank you so much for being part of this class. I'm going to see you in our upcoming class as we look at continuity of functions. Thank you.